Welcome to MLAC online tutorial. Before us is this topic, partial differentiation. Now, looking at partial differentiation is just the derivative between two variables while other variables are kept constant. Now, for instance, if let me make use of a cylinder as an example. Okay, now here is the radius, which is the same both top and bottom. Now the height. Now we know that the volume of a cylinder is given as pi r square h. Okay. Now the volume of this cylinder is dependent on two variables, which is the height and the radius. And what do I mean by this? It means an increase in either of these two quantities will result to an increase in the volume. Let us say, for instance, okay, let me make just use of this. If I decide to increase the radius, let's say here, okay, now with the height the same, I assume the height are the same. Okay, now the radius r1, radius r1. Now looking at this, now you can see that there is an increase now in the volume compared to this. Now take note that the heights are the same. Now I can also increase the volume of this cylinder by also increasing the height, and making the radius constant. Now in this case, I made the height constant and I increased the radius. Okay, same thing. Now this is just all about what? Partial differentiation. Okay, where a particular quantity is increased as a result of another quantity increasing while others are kept constant. Okay, now let us now consider this equation for which we can use to explain better what partial differentiation is all about. Now let us first of all, let us take note of this, that the y and the x is not the same as this data y all over. Okay, now this sign implies change in y to change in x, but this sign implies the partial derivative of y to the partial derivative of x. Okay, so in partial derivation, this is what we're going to be using. Okay, and this is what is generally being used. Okay, now let us now apply this equation using the partial differentiation. So if you are to find the partial derivative of the volume to that of the height, now what this implies is we are to differentiate v with respect to h, while other variable are kept what? Constant. That is that. Alright, now to that, now if I to differentiate v with respect to h, now we will see that h here will become 1. Okay, now so here we have pi r square. Okay, now this is the partial derivative of v, which is the volume, with respect to what? The height. Okay, now in the same vein, let us now find the partial derivation of the volume with respect to r. Now what does this imply? It also implies that we are to differentiate v with respect to r while others are kept constant. Okay, now to this end, now we are considering this equation. So to this end, if we are to differentiate v with respect to r, which is the radius, we tend to have 2 pi r h. Okay, alright, so the partial derivation of the volume with respect to height is given as pi r squared, and the partial derivation of v with respect to r is 2 pi r h. Okay, now this is just the beautiful trick of partial differentiation, and as simple as it is. All right, so that is just all we just need to know, and which is the basics of partial differentiation. All right, now let us look at some examples. Now let us look at these examples. Now for number one, now here we have u, which is a function of x squared plus xy plus y squared. Now if we are to find the partial differentiation of u with respect to x, now it means that we are going to differentiate every term having x, okay, and the others remain constant, and any term that is not having x, we consider that as a constant. Okay, all right, so to this end, now take note this x, we are differentiating this because it is x, so here you have 2x now plus, now we also differentiate xy, okay, this time rather, now because it's having a variable x, so to this end we have y, because when we differentiate xy with respect to x, x becomes 1. Now in this case, a y square is not having a x as a term associated to it, so we regard this as a constant, and when you differentiate the constant, it becomes what? 0. So this is the final answer. Now this is with respect to x. Now let us find that of y. So here we have it. Now with respect to y, it implies that we are differentiating with respect to y, while others are kept constant. Now in this case, x squared here is not having a variable of y, okay, or a term y associated to it, so we regard this as a constant, so it becomes what? 0. Okay, let me write that 0 here, then plus. Now to this end, if I differentiate with respect to y, y here is what? Having a power or a degree of 1, so which means differentiating it becomes 1. So here we only have what? X now plus 2y when differentiate y squared. Okay, so at the end of the day, our answer here becomes what? X plus 2y. Now for the next one here, number 2, we have that z equals x raised to the power of 3 plus y raised to the power of 3 minus 2x raised to the power of 2, then y. Now the partial derivative of z with respect to x, it implies that we are differentiating all for x. Okay, so with respect to x, so here we have 3x raised to the power of 2, then plus, now since y cube is not having x, now it becomes a constant, so that becomes 0, then minus, here we have 4 x y. Okay, all right, so to this end it becomes 3x raised to the power of 2 minus 4xy. All right, so with respect to y here, so with respect to y, now here this becomes a constant, so that's 0. Differentiating y cube, y raised to the power of 3, we have 3y squared, then minus, here we differentiate with y, so y becomes 1 here, so I left with what? 2x raised to the power of what? 2. Okay, so that is that. All right, this is the final answer. Now for number 3, now if you look at number 3, you can see it take the application of product rule, where you have that let's say y equals uv, which implies that you keep u constant, differentiate v, now plus keeping v constant, differentiating u. Okay, so this is the same rule we'll be applying, but ensure that see the same application here is what we're going to also follow. Now to this end, the partial derivative of y with respect to x. Now we are making this is u and this is what? V. Alright, keeping our u constant, we have 2x minus y. Now differentiating v. Now, and by us differentiating v with respect to x, so here it implies 1, and here is constant. I mean, yeah, it's a constant. So here you have 1 plus what? 0. Okay, now we've done this part, which is keeping u constant and differentiating v. Okay, now plus, now we are going to keep v constant. That will be x plus 3y. Now differentiating u, okay, so which is 2x plus 2x minus y. So to this end, we tend to have that will be 2. So that will be 2 because y here is a constant. So to this end, let me, for the sake of space, we have here 2x minus y. Now take note, this is 1. When you multiply, you have this, plus when you multiply through by whatever in the bracket here, you have 2x plus 6y. So giving us 2x minus y plus 2x plus 6y. Then this will give us, if we collect this, collecting like term, 2x plus 2x will give us 4x. Then minus y plus 6y will give us plus 5y. So that is the final answer. Okay, now the next one, the partial derivative of y with, of z with respect to y. Now take note, we are still applying the product rule. Okay, now keeping u constant, we have 2x minus u. Okay, now differentiating v, now we are left with 3. Okay, because x here is constant, it's a constant term, so here we have 3. Now plus the, so we are keeping v constant, that will be x plus 3y. Now differentiating u. Okay, and to this end here we have a negative 1. Okay, so which is negative 1. Open the bracket here. You might be asking, how did I get negative 1? If you look at it, here is a constant, which this one becomes 0. Then differentiating y here, you have what? Minus 1. So that's how I got minus 1. So here we have that change in partial derivative of z with respect to y will then give us, multiplying, we have 6x minus 3y, then minus x, because negative 1 times x will give us negative x, then minus 3y. Now collecting like term here, 6x minus x will give us 5x, then minus 3y minus 3y will give us what? Minus 6y. Alright, this is all about all we just need to know, which is the basic for partial differentiation. If you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in maths and physics. Also follow my Facebook page. Thank you and God bless you.